recorded. Are we sure it's recording? Recording on this computer. Okay, so these are the objective of the first session is to conduct survival analysis using Kaplan-Meier method on SPSS and data. We're going to look on how to compare the survival curve across factor category using log-rank test and other statistics, and run a Cox regression model and interpret the result with unadjusted hazard ratio, Cox regression with adjusted hazard ratio, check assumption of proportionality of hazard, and learn about useful SPSS commands and how to save your SPSS analysis. So again, briefly about survival analysis before we go into the, why it's not moving. Okay, before we go there, let me put it there. So again, just a wrap up. So survival analysis, as we discussed on Tuesday, is another type of analysis of cohort data that comes from cohort data. But the main difference is that in survival analysis, the main interest is the time to the event rather than whether the event occurs or not. And of course, this is warranted specifically when we have different types of follow-up. People join the study at different points in time. So the time zero is not the same for everyone. And therefore, as we demonstrated in the lecture, using the classical method of just looking at the mean time to survival, for instance, that could be. So if you are interested in time of survival, why not just take the mean, or simply whether the event occur does not really properly capture the experience of the participant, because event might occur at different points in time. They can occur early, so people like after being diagnosed can die after a year, while other can die after 10 years. So both have the event, but the experience is very different, specifically when we think about factors, how they affect a certain outcome, or treatment, how it affects a certain outcome. So the time to the event is important. So the time to event is the time surviving without the event. And when the event occurs, we call it failure. So we fail, we get the event, and then people are not anymore at risk. The most important thing about survival analysis is that it takes care of participant who has incomplete information. And when we say incomplete information, it means that we did not observe the event among those participants. We don't observe it if they leave in the middle of the study. They decide to drop out while they are where they are still free of the event, or they change their address. We lose them, and they might die from another event that's competing with our event, for instance, or non-competing. So it could be a car accident. So they die of a car accident, or they die of pulmonary embolism that might be related to the outcome that's in question. So competing or non-competing, or I finished the study because I have a 10-year funding, and then those people get out of the study without having the event, but they might develop the event. So I need to, the survival analysis actually integrate the experience of everyone, because their risk of having the event is considered at every risk set. What does a risk set mean? Let's say we have people who I'm following up for a year. The first event happens at 2, so my first risk set is at 2 months. That 2 months, I have people who were there, who were at risk. Some of them developed the event. So those who don't develop the event, they are part of that risk set at the beginning. And their probability of survival is considered in the first risk set. And then some of them, they leave. Okay, when they leave, they're not anymore at risk, but at least I'm assured that their risk have been integrated in the first risk set, and so on and so forth. So this incomplete observation, while we cannot measure a probability of survival when I have a censored data, however, I can consider their survival experience in earlier survival probability. And that's the difference, and that's really the very particular aspect of survival analysis. Now, survival analysis, we can look graphically how people are experiencing the event and how many of them are surviving, and we can create graphs. The most common and used is the Kaplan-Meier. I can compare different types of graph using some statistics that we were introduced to, again, like the log-rank test, which is the most commonly used. It's a chi-square test that would tell me whether the two graphs are different or not. But as also we can measure, we can have a measure of association based on survival data. And when I say survival data, meaning that I'm considering the time of the event, given that people have survived earlier time. Okay, so it's always this conditional probability and Cox regression. And there are assumptions in survival analysis, very, very important to keep in mind. The issue of that the risk stay constant and that censoring is independent of the outcome. So people later or of survival. So we don't want people who are censored would be more likely to survive later. So they are the healthier. And we don't want them to be the people who might really have a higher risk after we stop seeing them. Let's say they leave after 2 months, and then they are more likely to develop the event within a certain period of time. Sometimes we do additional work to test this assumption, but these assumptions are important always to keep in mind. So how to conduct survival analysis? We've done it on a small sample. You can do it manually. And I hope that you will be able to repeat, to go over the slide and try to do it yourself manually on that table. And you're going to have like a small exercise, not exercise, I mean a small problem in the final exam about it. So when the final exam comes, and we will be discussing the final exam or final assessment form later. So therefore, so I'm going to go over starting with SPSS, opening the data file. That's a data file on 146 participants who have a few variables. They have variable on sex, variable on age, variable on time to event, and the response, whether they died, and the treatment. So this is an example that's following up people who had two treatment. Treatment is a regular treatment, and let me open, and the treatment plus psychosocial intervention. Okay. And I'm going to get out of this presentation, because this presentation is for you. When you want to go over and to do yourself the survival, you have all the demonstration of where to go to SPSS, so on and so forth. But I'm going to open SPSS and do it for you. Okay. It's just to. Okay. In the meantime, if you have anything you want to ask or to say, please go ahead. Okay. So I'd like to add that, okay, I'd like to add that you also had the application and the a Word document for the application explaining what are these 146 records. So I'd like to repeat, because maybe I did not explain it very well. So these are 146 cancer patients who were followed up after a group received only chemotherapy, so treatment only, and the second was given chemotherapy and psychosocial support. And what we want to do, what we want to test is whether treatment is related to relapse, and specifically test whether the combined treatment is better. So it's less likely for them to relapse. So as I said, the data have sex, treatment, response, 0 is censored, 1 is relapsed, and the time to relapse in month. Okay, so we'd like to describe overall experience of this patient and compare the survival based, of course, on the main exposure, which is the type of treatment, and maybe look on how also the survival behave with the other covariate and the sex and age. And at the end, we want to use Cox regression to assess the association of the treatment with relapse, controlling for sex and age.
يلا حاضر يلا هاي أول مرة.
Okay. So let me open SPSS and share my screen. Okay, that's not, this is not the screen I want to show you, but give me a second to open my SPSS. Stop sharing. Okay, so you see my screen on SPSS?
Yes, doctor.
Yes.
Okay. All right. So my data is filed in my. Okay. Okay, give me a second to find my data. Subfolder. Okay, so that's my survival data. So when did you take are you still taking SPSS, or you only took SPSS in 300, 310?
No, we
No,
only
in
take
the
it on
310
the fall.
only.
Only in the main, on the core. In the
Yes.
core.
Yes,
Okay.
now only on Stata.
In 200
Okay.
meters.
Sorry. Okay, so I'm opening the data file. So my data file is already with the name of SAV. SAV, it means this is a data file for SPSS, an SPSS format. Anyway, you can always, if you have an Excel, the file is an Excel, you can always open it from Excel. So instead of opening data from SAV, you can always open different types of data. So a file, that's data file, can be opened from SPSS. So SPSS reads data that is data, Excel data, SAS data, and it converts them to SPSS. But when the file name is SAV, I mean the extension is SAV, it means that it is already an SPSS file. So I'm going to open the file. Okay, so open the file. Open the file. Okay, so do you recall the view for SPSS? How many of you really are comfortable with SPSS? Okay, so SPSS has two views. Okay, thank you, Noor and Bussola. Anyone else? Okay, so the SPSS has two views when you open the file. It has a view which is the variable view, which tells you what are the variable in the file, what are the label, if you have labeled them, what are the value label, and if there is any missing. So we have, as I said, it's a small data file with few variables that are made only for that exercise. We have sex, and I've labeled them as male and female 1 and 2. And then we have time. This is time to relapse. Again, time to relapse, which is important. Remember, the data structure for survival has to have two things. One is the time to the event, okay? And then the two is the failure, whether the event happened or not, or censored, yes, no. So either we observe the event, which is a 1. This is how all computers understand it. It means that there is a failure, there is an event, or you survive the event, and there is a censoring. So either you have the event or the event is not observed, which is the censored. So this is the time. So it means that when data are collected, you need to know exactly when the person joined the study and when that person was last observed, either when he or she dropped out or when he or she had the event, or the person stayed, let's say, from year 1 to year 5, which is the end of the study. So response is your event, treatment is your exposure, and treatment have medication only, which is chemotherapy, medication, and psychosocial support. And then age is left as it is, which is, a numeric continuous. This is the data view. So I have a variable view and a data view. I can also look at, I can view the data with its label. This is in the view. I can see view, value, label. So instead of looking at only number, I can see that this is a female who spent 3 months after treatment, no event, so censored, medication, and this person is age 33. And how many do I have? I have 146 participants. What do you usually do when you have data set? What would be the first thing that should come to your mind when you have this data set?
Like my
Meaning
outcome is continuous or categorical.
Okay, we know that. So we have defined them. They are already defined. So they are defined. They are all numeric because it's easier to deal with them as numeric. Okay.
Yes,
But they are. This is categorical data. Gender is 1, 2.
yes.
But 1, 2 meaning that I put a number when I coded the variable. That's why I put it numeric. What can you do when you have such a data set? Any data set, what is your first thing? So you clean the data, it's there, it's already on the computer. What would you do?
descriptive analysis.
So the first thing is descriptive analysis. So analyze. This is all recorded so you can see it. So descriptive
Doctor, we are
frequencies.
just asking on your screen.
You are not seeing me? You are not seeing the screen?
It's frozen.
It's stopped on a slide.
Oh, oops. Let me go back. Stop sharing. Oh. Okay. Okay, so do you see it now? Yes, because I
Yes,
see also
doctor.
the screen. Okay, so
We see
again,
time, response,
sorry.
treatment,
All right, so
age.
let me go back. So data view. So this is the data view with its label. And this is the variable view. What every variable is, all are numeric, and the value label. I mean, what does one means for male, for female, what does for gender, and 2 means. The first thing, as we said, is to do descriptive. So descriptive statistics to know what kind of sample I'm working with. So this is my frequency, and I can take all the variable, I highlight all the variable, put them in that box. I don't have to have a mean, median at this point in time, just distribution to see if I have any unusual data to know how many male, female, the range of time response, time is time to response, so on and so forth. Okay, so that's, again, do you still see my screen?
Yes.
Yes, doctor.
Okay.
Yes.
So the first type of file in SPSS was the data file that you just saw, and then when I run any statistics, I now have an output file. So this is my output file. Okay. So now I have a file called output1. It's not yet named because I still did not save it. It's output anything, any table, graph will go here. Okay, so I have the data, which is the survival data, and I have my output file data. So I have 38% males. I have times
It's
from
still seeing
0.
the variable view.
Doctor,
Ya
yes, can you
Allah,
share
la.
the output?
Yeah, we're not
Sorry.
seeing it. There is distribution.
Okay. Okay. All right. So this is the output.
Yes.
So
Because
gender.
it's a different tab, doctor. You have to share every time you change tabs.
This is what I noticed, and usually I don't run this kind of work on as online. This is the first time I do an online with SPSS, by the way. So we used to do it in the computer lab. So excuse me for this. So gender, time, response, how many event? So we have 45% who did not have any event under observation, while 54% relapse after a certain period of time. And the time of follow-up was from 0, and it could be 0 to 56 months. We have 58% who were on only chemotherapy and 41 on chemotherapy and psychosocial support, and the age ranging from 10 to 80. Okay, so that's very simple, yet it is very informative on the data. So how to start? I'm starting directly with survival. Okay, so analyze. Very simple in SPSS. Do you still see my analyze?
Yes, we
Yes.
see it.
Okay. So analyze survival. Okay, remember we have two ways of looking at survival, life table and Kaplan-Meier, right? The life table is when I have grouped data, and Kaplan-Meier when my data is ungrouped and I know the exact time to the event, right? So Kaplan-Meier, very important. So what's the data structure for survival is knowing the time, having the time to the event. This is the time. You see it or you don't see it?
Yes, we
We
can
see
see.
it.
Okay. And then you have the status. The status is the response. I mean, whether there is an event. The event is 1, and otherwise it is 0. It's always binary, if you remember. It's a binary non-recurrent. Okay, so it's 0 or 1. The event here is there's only one event, so I don't have any other option for the event. It's either relapse or no event, and therefore it's a one single value, which is 1, based again on my data. What is this box? يعني لنقول أنه you are following up people who are taking the treatment for cancer. What could be the event? It could be relapse, right? No event. So you don't observe anything during the period of the study, or the people relapse, so they have another, so the tumor grew again, they have metastasis. What would be a third?
The censored.
لا,
They
so
took.
one is censored. أقول ما في event, no
That.
event. So no
Oh,
event,
okay.
no event. Tell me censored, no event, or relapse, or died,
Yes,
right?
died.
Or relapse, or maybe they are cured. For instance, let's say that no more lesions. So therefore, you have to specify what is the event that you are looking for. Either you are looking for one event, which here I have only one, which is either relapse or no relapse. But sometimes the data is 0, 1, 2, 3, 4. So you might decide that any other event which relate to progression of the disease could be 1. So therefore, you have a range of values. So here we have only a single value. So here, if I don't do anything here, what I would get is the first thing that we discussed in class is the overall survival experience. So overall survival experience. I don't need to save. I can save the survival, but I don't need to survive. I don't want to save the survival data on my data file. This is what it does when you say save. It means I add up to my survival data on the survival, on the probability that I don't need because I'm not using them. Option can be, what is it that I want to see? So I want to have the survival plot. Usually this is what I want. Survival table is the table where there is this computation of every single event that happens, like the one that I showed you also in class. I can show it to you. So continue, and please let me know. But before I move on, there is a third type of SPSS files. Anyone knows what's the third type of the SPSS file? So we have a data file, an output file. So if you
The file with the code, like
the file with the code,
chapter on your
exactly,
video.
Mariam. So do you know how to get the codes? So before,
I do.
okay, Mariam, you do, لأنه you've done some work.
Yeah.
Okay, great. So thank you, Akul Hal Mariam. You can say, so before clicking OK, so SPSS is so simple. You can just click OK and get all the output. But in order to document and save all those commands, yani do file, yani for you is the do file, which equivalent to the do file in Stata. I can just click on paste. When I click on paste, and I know that now you're not seeing anymore, right? My screen. Are you
Yes.
seeing my screen?
No.
You're saying,
We are seeing a table that showing the frequency of age,
no,
a descriptive
that's
frequency
why.
of
So
age.
because I moved to another now file.
Yes, you could share all screen.
Okay. Okay. So now we have the file, which is what we call is the syntax file. Okay. So this is the syntax, is data set activate data set 1. This is the data set 146. Kaplan-Meier, KM is Kaplan-Meier. So I want to have a Kaplan-Meier graph. Response is 1. I need the table with a mean and to plot the survival. So I block all this and I do a run. Now I should see the output file. Tab content only over the shoulder. So can I do all of it? Control. So
Is there an option of share entire screen?
this is what I'm trying to see.
Mm.
So and there should be, every time I move to another screen, it should capture the screen. I'll see it. I'll do it again. So you see the survival table?
Yes.
Yes.
Okay, great. Any thoughts? So remember, the survival is only calculated when the probability of survival.
When we have an event.
Exactly. So the first event here is at month 4.
Yes.
All right.
The
So you
other
say
three
it,
are
right?
censored.
قبل ما في كله censored. So therefore, they give us the estimate with the standard error and the number of remaining cases, which are the one that remains at risk. So we lost all these, and then what remain at risk is 140. It's not exactly the same table I showed you, but nevertheless, this is really the way it is calculated. So all of these, no event, and then when it comes to relapse, I have several ones that relapse after month 7, okay? And then the last one, it calculates everyone, so the probability of all these people who relapse, so who relapse at time 7 months, and then how many at risk. So this is exactly the same. I don't like this kind of table when we have a lot of number, but nevertheless, this is only for you to see how it is calculated. So we calculate the probability only at the time of the event. We have so many 14, so many participants who had the event at 14, so on and so forth. So that's for the table, which is again not informative. I would not put it in any of my output, but only to see how things are being calculated. And then what I ask for is median and mean and median survival time. Of course, the mean in such data would be usually skewed. It could be skewed to the right, skewed to the left. So here it says that the mean survival time is 33 months. And then with the lower and upper boundary. However, the median, which is the time where 50% have developed the event, is 28 months, which is good. It's good to have. So when you report, and I will tell you, would you like to report some summary statistics on survival? You can say the mean, but again, the mean is not informative because of the skewness of data, but nevertheless, one of the good summary statistics in survival data is the median survival time, which is the 28 month, as you see it here. And this is the survival function. Okay, from that this is an overall experience of these 146. And here is at every drop, this is a step function. At every step, as every drop, it means there is a calculation of probability of survival. So we have a probability of survival here that's calculated. And since it is cumulative, its probability of surviving here 7 months and beyond. Remember, we have 4. Here's the first one at 4, right? Do you remember that we have one event at 4? So here we have a small drop. And then we have another good drop. So these are the censored. And then we have a good drop here, which are the 7, 8
Doctor,
people.
drop in terms of what?
يعني drop in the
Drop in
number of
terms of
people.
what?
لا, كل drop is when the event occur, because we calculate the probability of dying. So نحن we calculated here, okay, at 4 months, right? We
So
had
why we
100.
have at 1, why we have 4 consecutive pluses and the
ماشي,
trajectory
it's
didn't change?
لا, it's still the same. ماشي, I don't know why they put the pluses. يعني I'm not sure why they put it, but all are these censored. ده كوينه censored. These are the censored, and then we have the event at 4, and then we have another event at 7, and then we have another event, I think, at 12. So this step function or the calculation of the probability happens when we have an event. So it remains like this, and then it drops, and then it drops, and then it drops. Okay? So these are the survival function, and then these are the censored. Here are the censored. Okay, I don't know why they don't have for everyone, but I don't have the data in front of me to make the comparison. So nevertheless, this is decreasing. So people are relapsing as the time goes by. And I think at 55, yani they most of them have relapsed by 55 months, right? So we have the last observation at 55 months, the one that we have seen before. Okay, so what next in survival? Next in survival is to look at how the treatment is related to the survival. So are there different survival experience based on the treatment, chemotherapy versus chemotherapy plus psychosocial support? So this is, again, going to analyze. I'll try after this to maybe share all my screen and see how it works. Is survival, again, in the Kaplan-Meier, similarly in the Kaplan-Meier, and let me check that you're seeing this.
Yes, doctor, we are seeing.
Okay, so now I can add the factor. The factor is the treatment now. Okay, and then I have these, how to compare the factor. I have the log rank. Remember, these are what they do. These log rank, Breslow or Taranware, they compute expected number of events if the survival is not different, and then there is a chi-, and then we calculate a chi-square that compares what we observe and what we expect if there was no difference in survival. So I can show you the three. Again, what are the difference between these three test statistics? If you had a chance to go over the survival, do you remember what are the difference in those statistics? That shows me, that only show whether there are statistically significant difference in the overall survival experience. What is the main difference between the different type of statistics? Any thoughts? Okay, so it's only thing that log rank is sensitive to later differences in the survival. So you know that survival curve, maybe they are at the beginning very close to each other, and then they divert at the end. So log rank is very sensitive to later differences in the survival. Breslow and Taranware, or Breslow, I think, is at the beginning, and then Taranware maybe at the middle or something. But it's usually they do give you very similar result. But anyway, we will check. Again, option, I will remove the survival table. I don't need to see the survival table broken down by treatment. This is too much information, but I would like to see maybe the difference between mean and median survival between those who are on chemotherapy compared to those who are not on chemotherapy, who are on chemotherapy and psychosocial support. And then again, I can go to paste. And if I paste, let me check how I can, okay. I'm not seeing actually, sorry, I'm not seeing any option that says لا خليني هيك content only. Shoot. What did I do now? Sorry. I'm going to go back to the output, not to the output, excuse me. I want to go to the syntax. Okay, so the syntax now, I have the command for the Kaplan-Meier by treatment. I can run. Okay. So what do I have? Do you have?
This is our Doctor, this is our first time to see SPSS showing codes like this data set activate.
But it's okay. I know when you do it in 310, actually the purpose of doing SPSS is not really to teach you SPSS, but to do some analysis on SPSS. But when you are trained on SPSS, usually you take more information and learn more skill on SPSS, which is fine. It's okay. Now you're learning it. So again, I want to check
Yes,
my
Doctor.
screen.
Like my point is, what is the? I'm not asking. My point, why we are looking at these codes?
Why?
This is
Because
yes,
now, okay,
this is
so
my question.
okay, so thank you. Sorry, I misunderstood your question. So the question is, the issue is if you don't save your codes, and let's say you add data and you want to redo your analysis, you have to redo it again. While if you save your codes, مثل الدو file. Why do you do a do file? You write your code, right, on the do file.
Yes.
I know that you
Yes.
write but you can do, here you learn, the more you save your file, the more likely you can know about all the codes and you can write them yourself. But in SPSS, it's not about learning how to write your command, but saving the command in case you want to rerun the analysis again. So you have a syntax file that has all the do file, all the command that you have run before, maybe on a subset of data, and now you can do it again. Let's say you do recoding, and then you have a new data set, and you don't need to do recoding again. You can run whatever you have, and then you know what you have done. You keep track of what you have done, all the operation and the command that you have done. But of course, SPSS is very simple because you can just click OK and have the output, right? You don't want to go into syntax and know why am I learning the syntax. ما هيك نور? You're just saying,
sorry,
why do I
Doctor.
need to save? So you save them for your own information, for tracking what you have done. And if you want to rerun the command, you can do them. Okay. So now you see my screen, right? You see the output.
We still seeing the data set activate
The codes.
the codes.
Okay, so this is the output. So the output now, as we said, we have done the Kaplan-Meier by factor, meaning by medication and medication only. Now we can compare the median and the mean survival time between those who took medication and those who are on medication and psychosocial support. Anybody would like to interpret?
Yes, Doctor.
So what would be a message? What would be yes? Go
Like
ahead,
for those who are only on medications, 57 out of 86 developed the event.
Okay.
However, for those who are on both medication and psychosocial support, 22 out of 60 developed the event.
Okay. All right, great. So we have percent for the event, which is good. So you are comparing actually probability of event among those who are on medication compared to those who are not. Is that what we want from the survival? Anyone else, please? So this is one way of reading the data. It's excellent. So you're saying that if I take two groups, each one has a different type of treatment, and then what would be the probability? This is the binary. right? This is the binary, and either event or no event. What else? What additional information we can
Yes,
get?
for the second
Noor, can we
table,
get, please, can we have other people
yes,
answer,
surely,
please?
doctor.
Thank you.
Yes. We can also see the time to the event in the second table. For medications only, it is 29.5
It's
versus
not
the
time to event.
psychosocial
Can you,
time
yes,
to
it's not time to event,
survival.
Rula.
Time
No,
the
بس read it. It's
survival
mean and median. What is it?
median
Can
time. Oh, means and median time for the survival time. The mean time is for medications only is 29.5 versus medication and psychosocial support is 39.8
and that's the
versus
median also. Yes, not
versus the
versus.
median, while the median is 21 for medication only versus medication and psychosocial support is 42,
Yes.
which is
So
greater.
what is it? Yani, can you just conclude regarding this information on surviving and medication?
Yes, so there is more survival time. The survival time is higher when there is medication and psychosocial support versus medication alone,
Okay, so we can say on average, right?
on average.
Okay, so but again, those averages, as we said, are not very accurate in terms of the
Yes.
average, but at least we can look at the estimate in terms of the median and say that the median survival time is much higher, right? This is much higher median survival for those who are on a combination of intervention, right? It's clear, right? Right? And then we are using the time. So
Yes.
we use the event at the beginning, we use the time. So what is next is using the time and the event and the number of event, which is the survival curve, right? So can I have someone else, please? Noor? Oh, Maggie, go ahead,
Yes,
Maggie.
yes,
You
doctor.
unmuted. Go ahead, Maggie,
Yes.
please.
According to the curve and the table above it, those patients who were taking medication and psychosocial support had significantly better survival outcomes than those on medication alone, as we can see from the three statistical tests. The p-value is always significant.
Great. Anyone else would like to say something, to add something to the... Yes, Abdulrahman.
I think, Professor, we can also comment on the difference in the graph. No, the graph of the patients which had the medication and psychosocial support was more pushed toward the right, I think. No.
So it's better survival. So at any point
Yeah.
in time, except for at the very last, the survival at any point in time, even if we can see at
Was
different
more
point in time,
in
they are definitely, if we put like 95% confidence interval at every occurrence of the event, the red one is much better. So more people are surviving, a higher probability of surviving at every single time period. Remember, in a survival time, my x-axis is time and my y-axis is survival. And as Maggie said, the three statistical tests that are particularly, these are chi-square tests, log rank اسمه mental Cox, if you want, some people refer to it as mental Cox, but used most commonly as log rank. Breslow is the generalized Wilcoxon, which, as I said, is the early differences in the curve. And as you see, anyway, at the beginning and at the very end, even here, we see differences in the experience. And it's also at the middle. And the three chi-square, the three statistics actually are statistically significant. So overall, the experience of the survival experience of those who are on a combination of treatment is statistically significantly better. Two is that the mean survival is much higher for those who are on a combination, and the median is also 42 compared to 21 who are only on chemotherapy, right? So this is the first statistical inference that we can make from survival analysis. Again, an overall survival by a specific factor, and of course the main factor is my exposure. At this point in time, the only thing that I can do is that compare, is the survival better or no? more people are dying, more people are surviving, yet I don't have a measure of association between the treatment and the response, which is the relapse. So then I go to further doing more inferential statistics, going to Cox regression. But before going to Cox regression, I would like to try to look at the survival experience by gender, okay, because gender is a factor, it's a categorical. I can actually pick up 2 or 3 groups. However, with age, it's very difficult to show a Kaplan-Meier with age which is continuous unless I recode age into categories and then I show the survival curve by category. So let me first do again another analysis. So I want to analyze survival, and I want to do a Kaplan-Meier with changing the factor from treatment to sex. You see the command or no?
Yes, doctor, we are seeing.
Oh, okay, great. And then, okay. And I think you still see my output, right?
Yes.
Yes,
Okay,
doctor.
great. So this is the survival by sex. Okay, of course, looking at the graph, we don't see much differences except at the very, very beginning. All right. However, I have data showing that the mean are very similar. The median, except the median for the female is different. Okay, but otherwise the mean is different. But the overall survival based on the log rank test and the Brestow and the Taranware are all not statistically significant. So does gender affect, or is it related? It doesn't look like related to
No.
relapse, right? Or survival. Okay. Okay, any idea how to do recoding in SPSS?
What
Okay,
I know about recoding is that you put a code and it gives you an output.
Now, recoding meaning that you have, let's say, the age category, and the age category, as we saw, if you recall, is from 10 to 80, right? And if I want to make it groups, how do I do it?
So you do it from the data view.
The
You go
old
and you create a new category.
Yes, how?
You
لا,
transform from the transform.
No,
Yeah.
transform, yes,
Yes,
transform.
recording. We learned this in the fall. Yes, surely.
On SPSS?
Yes.
Good. Okay, so I'm asking you how you do it.
From
It's just an opportunity for you to do it now.
Yes, you recode it. Okay.
Okay, so you
Transform, compute, record into different variables.
Into
Yes.
different variable, exactly. So my age,
We
I
can
want
call
to
it
make
age group, let's say.
Age
group.
underscore category.
Okay, age group is age group, and then I change it, and then I go to old and new value, and I would put, let's say, 1 for. So
We
not
want
1.
it range.
Sorry, not
We
1.
want range.
Sorry, a
You
range
click on
of
the
10.
range.
Let's say 10 to, then we'll 10 to, oops,
To
10 to 30, 10 to 25. So young people is 1. I just want to see if I see any. So add 26 to maybe 44. This is very arbitrary. Okay, 2. I don't have too many data, 146, maybe 45 to 64. Oops. Okay. Sorry. Okay. This is 3, and I add, and then I'll do through highest, I would take 65 and above. I'll make it 4. And then I will add, and then continue. I'm not going to the syntax. No, I don't want to keep shifting screens. So if I just say, okay, and now I analyze and I do my survival by, instead of sex, by age group. Okay. Let's see what happens. It's still, although there are some differences at the very end. Okay, so the blue is the young people, which is evident that the young people have better survival. And then but the three other group are so close to each other. But I would say that if we are to do like only young versus old, maybe we could have find a difference. But overall, because the log rank test also is an overall. It's all expected minus observed, the sum of expected minus observed. So the sum of expected minus observed again is not statistically significant. So although we see a better survival for young people who are 10 to 24, however, the survival, overall survival is not the same. However, if we are to do differences in mean, we could have found statistical significance because the one is 41. So if we are comparing like each to the young people or the young to the old, we would have found a significant difference where definitely the young people have a better survival. Survival mean time to relapse. Okay, time to relapse. This is important to note. So this is with respect to Kaplan-Meier and looking at whether there are differences. This is the first statistical inferences. Now, what's our second last analysis is to look at what measure of association, because ultimately what we want to say that a treatment is related to response, right? And what is the likelihood of response for those people who are treated in chemo compared to those who have two combination of treatment, or what's the likelihood of response in those who have intervention, two intervention compared to one treatment, type of treatment. So irrespective of which one you want to have as your exposure, it depends on your hypothesis. So are you saying that treatment two, which is the combination, is superior, and therefore we expect what? Less response or more response? A relapse? Less relapse, right? Less relapse, including and not less hazard. So we want to think about hazard rate. Why? Because we are integrating the time to the event, and therefore we want to do Cox regression. So analyzed survival. It's all under survival Cox regression. So in the Cox regression, the first thing to do is I want to have an unadjusted association. And if I want to do unadjusted association, what should I consider only? The main exposure. So first, always in the survival, I need to define the time, define the status, which is response, having the event or not having the event, continue, and then put only the treatment. Why put only the treatment? Because now I want to produce an unadjusted hazard rate ratio. So what Cox regression does, it model the hazard rate ratio. Okay, hazard rate ratio, as we said, is an instantaneous risk that is built on people having the event, given that they have survived a previous time. So it is actually based on survival data. It takes into consideration time. Similar to any other to logistic regression when you do it, or else when you have a binary categorical exposure, you need to have a reference category, right? So in SPSS, every time you want to check which reference, you put your covariate or your factor, and then you go into categorical, and here you define which is your indicator. So what indicator you want to put, the first or the second, and what does indicator mean? Janine. So I want to build a Cox regression by including only one variable. Well, by including one variable, it means I'm calculating a hazard rate ratio, unadjusted. Okay, so what does an indicator means? What does a reference mean? And a variable that is categorical.
Anna, I wanted to say that the indicator in this case would be our reference.
Yes, which means that my hazard rate ratio is 1. So which one do we put? The first is my treatment, my chemotherapy. So let's say that putting the I want to show that the combination is better, right? So let's
Yes.
see the combination compared to only one. So I'll keep the first as my indicator, okay?
Yes. And the combined, I will compare the combined to the treatment alone.
Excellent, yes. And I would expect that the combined would have a lower hazard rate ratio. So what
Yes.
I need to add from here only in the option is to have a confidence interval. The confidence interval of the exponential of beta. Why? Because in Cox regression, the coefficient, the B, is the log of the hazard rate ratio. When I take the exponential of beta, I get the exact hazard ratio. So the table would give me the hazard rate ratio instead of doing it again or asking for it. So this is very important that on the option, I put the confidence interval for exponential of beta. And there is something else in the plot. And I'll talk about it in a minute. So the plot is, you can have the survival. We've done it already. I want to do something called log minus log. And I'll tell you why I'm going to do it. So we put log minus log, and I want the value, the plot by treatment. This log minus log is a way graphically to check the assumption that there is proportionality of hazard. So it tests the proportionality of hazard. You don't want your probability of survival or of the hazard rate ratio to change between the group as the time goes by. So to account for this or to check for this, what you do is you check the plot. So you plot the survival, so this log minus log, you plot them, and if they are parallel, it means there is no violation for the proportionality of hazard. So I will continue and then I will show it to you in a second. I'm not going to go into the syntax. I'm going to do it directly from here, so that's okay. So I have, as before, I have 79 who relapsed, 62 who were censored. I don't have any missing value. I have some censored before the earliest event and stratum. This is like the what we call the left censored. And then I have 86 who are on medication, 60 who are on a combination. That's the data that I have. It's good always to see the first table, although there's a lot of information, but at least you check whether everything is in the right so as was it Janine noted, so we have our exposure now is the medication and psychosocial support compared to the 0. It means my medication only. Okay, so 1 0. So I have the first, this is the goodness of fit of the test. So if the test is significant, it means that whatever I see, that only that variable is statistically significantly fit the model and explain the relapse. And then I have, that's my, you see, right, the variable in the equation. So I have only one variable in the equation, that is treatment. So the B, it's telling me that there is a decrease in the log of the hazard rate ratio if I have a combination of treatment compared to the one chemotherapy. To understand it more, I look at the exponential of beta. So can Razan explain the exponential of beta, which is equal to the hazard rate ratio, which is similar in terms of interpretation to any relative risk. So can I, Razan, hear you interpreting rate ratio of 0.546? Razan, are you with us? Okay, I'm going to ask the second one I see on my screen. Busola, can you interpret the 0.546?
Okay, so since the p-value here is statistically significant is less than 0.05, can
Great.
conclude
Okay,
that
so the association, the relative risk is significant. Can you please interpret the 0.546?
So we can conclude that looking at the unadjusted
I don't understand you
exponential.
well. I don't know. Is it your microphone? Do you hear us? So maybe
Yes.
I'm not hearing you well, or others are hearing well?
No, the voice wasn't so clear.
Is it better now?
Sorry? Bussola? Bussola? Okay, Mariam, please, can you interpret the 0.546?
Yeah, sure. So the sorry, في شوية background noise.
It's okay. But you're clear, and I mean, I can hear you well.
Okay, so we can conclude that being on medication and psychosocial support is statistically significant.
Okay.
Shared with being.
Okay, can you interpret the 0.546, Bussola?
Can you hear me?
Sorry, maybe I'm not being clear. I heard you well, Bussola, commenting on the significance, which is the p-value. Excellent. And this is, yes, it is statistically significant. Therefore, the treatment is related to the risk of relapse, right? So the second question is how it is related. Can you interpret the exponential of beta, which means the hazard rate ratio or the relative risk? Tasneem, can you please interpret the 0.546 as a relative risk?
The risk of developing the event for those who are in treatment on chemotherapy alone, on chemotherapy and psychosocial support is 0.546 times that to those on treatment only.
Great. Or we can say that it's like 45% less risk for those who are on a combination of treatment, right?
Yes.
So we can say either they are less at risk, what's the percent, or it is related, it is those who are on combination are 0.546 compared to those of those who are on chemotherapy alone, which means that it is a better, again, lower risk of survival. Okay, so now this is what you see as the minus log minus log. So usually when the graph or the plot are parallel, it's more so you can say that there is no violation of the assumption of the Cox regression. So this violation is tested by a graphically by log minus log, or by something else. We can see it in a minute. That tells us that yes, you can use the Cox regression. You are allowed to use the Cox regression if there is a violation. Again, if there is a violation of this proportionality of hazard, then we have to create a term that is called treatment times the time. Yani we have to see then the regression as the Cox regression or the hazard with time. So we have to account by time. Otherwise, if we don't see this proportionality of hazard, meaning things are changing, are not constant over time, then we are okay to use this regression. Otherwise, it's not like we can't use Cox regression, but we have to add a term to the regression, which is treatment times time. Okay, so that's it. But here we are okay. So this is, so then for the unadjusted, so again, this is the unadjusted relative risk is 0.546. Let's see if we add, do you think that if we add age or gender, this will change? Yes. Why? And no,
I think
why?
age, yes, because maybe the way the coping with the disease actually differs with the age, maybe.
Okay, so that's
And
okay.
maybe
All
older
right.
people would show less effect of the.
Okay, so when we want to adjust, what does it mean? We want to control for confounder, right?
Yes.
Yes. So confounder they have to be associated with the disease. What you said, Abdulrahman. So young people, etc. But they have as well to be associated with the treatment as well, right? So there
Yes.
should be an association. We did not check this, but at least we checked age and gender with survival. Did we see any difference? We did
No.
not
No, we
much,
didn't.
right?
For
But
gender,
anyway, yes, not for gender, little bit for age. But anyway, let's do now a regression where we calculate adjusted hazard rate ratio using Cox regression and doing a multivariable Cox regression. So analyze survival Cox regression. So time response, now I would add age group. I'm going to add age group, not the age as is, and sex. And since they are categorical, I will define my age group as the older one, or the younger one. Let's put the older one as the last one as the reference, like 65 and above, since we're looking always at protective event. And then sex, we're going to put first is male, female, so keep it as such. Okay, let's see, I right click to see. So male is the first, so therefore my reference is male, so female compared to male. Continue. Anything else, the option is there, confidence interval, continue. I want to now see the plots, the log minus log in the multivariate to see how, again, the behavior of the treatment is. If there is, again, a violation. Actually, I can do it for every single covariate, but I don't really care about the other covariates since they are not actually even related. But you can do it for every single covariate, but you have to put it one at a time. Okay. So now again, the same analysis, 79 event, 62. Now we have more data, more information on sex, treatment, and age group. Again, treatment is the main exposure and my main hypothesis. Is the model significant? Actually, not too significant. 657. It's 0.11. If I consider that one-sided, it might be like a borderline significant. And then the change, as you add steps, I mean, it's not much change. So I think it's really the treatment that's the most important ones. And as a matter of fact, again, let's see. So the treatment now is associated with 0.511. Before it was 0.546. So it improved a little bit, right? So if you see here, the exponential was 0.546. It became smaller, a little bit smaller. And for me, this is not a big change. So it remains significant and protective. So somebody who is on a combination of treatment is have a better survival and a lower probability of relapse compared to those who are on chemotherapy alone. In the presence of the other variable, this did not change much. It's still significant, changed slightly. And as a matter of fact, those age and gender did not make a difference. And if we take each one alone, they are not statistically significantly associated with relapse, neither age nor gender. Is that clear?
Professor, how would we interpret the like the values 1.038, for example? How do we say
Which
it
1.08? Sorry,
in
guys.
the age group 3?
Age group 3. Okay. Like our sheet, it's not significant, right? The significance
It's not,
is point.
because
I
in my
don't
case
even
it was.
interpret. I just say overall age is not significant. The only one that shows protection is the age group 1 compared to the older one. The last is the
The older
reference.
is the reference.
Yes. So there is, so the hazard rate is towards the protective side. However, it's not statistically significant. It could be related also to sample size. We can see how many are in the young age group, but all others are almost 1. يعني the P is almost 1. So all these are almost 1. يعني ما في association. مش هيك. What we say is no association with of age and gender with relapse with the event, simply. And if just to check, so شوفوا, we have only 16 person who are young. And I would say if we had more, our ability to find statistical significance would have been better. Do you agree?
Yeah, of course.
Yes.
Okay. Others, do you agree? Why? Because if we see the magnitude of the association is pretty good, 0.546. The significance is 0.14. So I would say that it might be related to a small sample size that did not allow me to reach statistical significance, but the data suggests a protective effect of being young. Okay, so this is all what I can say, that being young, or the data suggests it did not reach statistical significance. This may be related to the issue of power, because I have only 16. And again, if I want to show you the minus log, it did not actually change much. It's still parallel. I would say that it's an okay, and I don't have to have a treatment time component, because it looks like there is no violation for the proportionality. Okay, so again, what we did quickly. So we did the frequency table just to see how the data are. We look at the Kaplan-Meier. This is the life table that we do. We did it manually with this 12 participant in the classroom. Again, this is to emphasize that the probability of the event and probability of survival is calculated whenever an event occurs, and whenever there are no event or censored, this we don't have any calculation. However, the experience of those people is included in the previous survival, and that's why we say those with incomplete data, we still have their contribution. They still are accounted for. We call them incomplete observation, whatever. So that's the survival analysis, what it does. So it makes use of all the data. The Kaplan-Meier, the simple one graph Kaplan-Meier gives me an overall experience. Again, the Kaplan-Meier can have, it never increases, of course. You start with 100 and then you decrease. This might reach 0 or not at the end of the follow-up period. Everyone would have the event, and maybe only a few would have the event. Okay, we can calculate how many had the event, probability. We can calculate the mean time to event, the median time of the event, and the log-rank task is used to compare factors when I look at the overall experience, a survival experience. We've seen that. And then treatment at the unadjusted level. When we compare treatment factor and with Kaplan-Meier, it showed that there is differences and it was statistically significant. But to look at the magnitude of the difference, we did Cox regression, unadjusted first. So unadjusted, and just having only the treatment actually was a significant model. The other model actually did not, the other variable, age and gender, did not add anything to the model. It did, the assumption of proportionality was not violated, and at the end we did multiple Cox regression. Cox regression is again for survival analysis. Any questions? So what's the
Doctor,
difference
I have
now?
a question.
Yes,
When the exponential beta is usually lesser than 1,
yes.
we
It's
usually
protective. It means
yes,
the
and
factor is protective.
we say 1 minus 0.46. equals, which is in this case 56%. So we
مظبوط
say
56% lower risk of relapsing.
relapse. Okay.
Yes, of the event. Now this is SPSS. Let's go to Stata, your favorite Stata. So I'm going to close. I'm not going to save anything because you can do it yourself. Okay. Do you want me to save? I'll save and put it, and then you can check your. So let me save the output. Output survival 20. I'll put it on my desktop and oops. And then upload it so you can see all. The syntax, okay. All right. So now I'm going to go to the data on Stata. So the data also, Stata is also on your, on Moodle. And it's called class application or Stata class. So it's the same one. So what's the difference between SPS? So let me share first, sorry. I'm sure most of you are going to prefer Stata. Okay, so that's data. I'm going to open the data. It's already there because I opened from my directory. Okay,
Yes,
you see it, right? Yes.
Yes.
Okay, great. So what is, of course, a very simple command in Stata, but also it can be used. You can use the menu, and the menu here and that is survival analysis. What is important, and what's the difference between SPSS and Stata and survival? The main thing at the beginning is that you have to inform Stata that you are dealing with survival data. And to do that, you have to set your data as a survival data. And the command is STS, survival data setup. You can do it like this directly. هلا بنشوف you will see the command. So survival analysis setup utility. And by the way, I gave you the command in the presentation. Okay. So you have to declare your data to be survival data. So to declare it again, what's the structure of the data? Again, you need to the time and the failure time. Failure means the event. لأنه نحن survival is surviving the event. It means that the event is a failure time, right? You survive and then you fail and then you have a relapse. So failure
Here
time.
the response?
The response, exactly, 100%, okay? And the failure value is 1. I think you put 1. I'm not sure you put 1, but nevertheless. So here are the information. We have, so it did set it up as a survivor. Now the failure event response is 1, observed 0 1 time, exit on or before the failure. We have 146 observation, 1 observation ends or before we have any event. We have 145 observation remaining, 79 failures, that means 79 event, and last observed exit was at 56 months. And it's nice, it gives you also the person years at risk, which is 3459, the 3459 month at risk. Okay, so similar to I can do the graph or the Cox regression. So the graph is again survival, but again they are very simple. I can let me just open my thing. Okay. So I can write them here. Okay. So simply, okay. So I just want to put this up. Okay, STS graph, STS graph. STS graph is Kaplan-Meier. It's so simple. And it's the same one that you've seen, right? You are seeing my screen, right? or not? Are you seeing the output? The
Yes,
data
yes.
output?
Yes, we're
Yes,
seeing.
Okay.
yes.
So that's it. So, and if you want to do it by gender, again, I think it's a comma, if I'm not mistaken, by sex. Like, but without the, maybe without the comma. Sex. Like I'm not a very, I'm not very competent and very experienced in this data. So I wanted to just do it. Sorry. Let me repeat it again. I think it's stratigraph by sex. I've done it before. Okay. Okay. So isn't it easy? So look what happened to the data set. Sarana ST survival, the time. So it does produce all this structure of a survival. That's very important. And that's actually the main difference between SPSS and Stata. Otherwise, I mean, it will produce for you this exactly everything the same. We can do STS. Okay, let me do it. STS graph. What's the most important thing I want to do is by treatment, right? By treatment. Ta-da. Okay. So that's the Kaplan-Meier. And if I want to have the, so I think it's STS test to give you what do we need when we compare the two graphs?
The median and
not the median.
Logrange.
The
The
Logrange.
Logrange.
STS test. Okay, Allah. Is it STS test? I think it's STS test. Okay, خليني أشوفها هون. Let me see it here. Not here. Summary test table. Describe, tabulate, but causal graph. Should data convert report. I forgot actually, but it is a test, STS test, or let me go to. Okay, I need to ask help from ChatGPT. 1 second. Log rank and data. You'll definitely become much more competent on survival and data. So it's STSS. Oh, I need to put the group variable. Okay, so I need to put the treatment. So what is missing? You still see my data, right?
yes.
Yes, doctor.
Okay. So it is STS treatment. What needed is the treatment. Okay. All right. So that is the chi-square. Chi-square is the log rank. Okay. So this is telling me that the log rank test is 7.49 and the probability is 0.0062. And these are, again, if you recall, these log rank test and Wilcoxon test are tests that compare the observed, these are the observed event, with what's expected if the survival were the same. So these are the expected event, and it's just 57 minus 46 over 40 squared over 46 plus 22 minus 32 squared over 32. It's exactly the chi-square calculation that we know, and you can check it if you want. So the chi-square is more than 3.84, is 7.49, and it is statistically significant. And therefore, the difference and the survival overall experience is statistically significant, right? So do you recall it's the same, right? Okay, and then if we want to do the Cox regression, and if you want to we'll do the Cox regression and then we will test the proportionality of hazard. So the Cox regression is
Doctor,
again
it's ST Cox.
ST Cox, yes, thank you. Yes. We'll do the ST Cox again, gender and treatment. كلها سوا ST Cox. Okay. ST Cox, sex, treatment, and age. Of course, here we don't have the age categories. Okay, and then here it is. So treatment again, but okay, so here is it. So again, of course, if you recall the adjusted hazard ratio when we had it in as a multivariate, but with age grouped, it was 0.511. Do you recall, ladies and gents?
Yes.
So this is the my measure of association. It's just the layout is a bit different. So it's telling me that, again, there is a significant association. Here is the P 0.011 with a combination of treatment much better and reducing the risk of relapse compared to people who have only chemotherapy, and it is significant. The other two are not statistically significant near the age as continuous, although it looks like an increase of 1 year of age is associated with an increase in the hazard because it's 1.00. However, this is not statistically significantly different. The model is significant. It becomes significant when age is continuous, and that's it. It's quick, easy, very neat. Of course, you can add the mean, the median survival. There are options of adding all the other statistics. So the difference in SPSS, the default gives you all those statistics, and the default gives you a lot of information. Here, the Stata, you have to ask for all the information. And if you want to check the proportionality of hazard, it's STPH test. Okay, and okay, so the global test. So there is a global test. This is a global test for all the three variables. So a test that is more than 0.05, it means that no violation. Okay, so I repeat, a test whose p-value is 0.5 and above, it means that there is no violation of proportionality. And I think the violation comes from the other variable, and that's why if we put treatment alone, I think the test would be better. And I'm going to do it. So let's put ST Cox and let's put the treatment only. Okay, and then do the according to the test, it's still there is a violation of the proportionality of hazard, and this means that we have to take into consideration the time. So I think I'm not going to go a lot on this, what to do, because most of the time we don't take only the treatment. There should be many more covariant to check at the end whether the proportionality of hazard is violated or not. At least what I saw in the graph of the log minus log that we can do as well here, that they were parallel. They were parallel over there, right? Or not? And SPL. Let's see, survival, regression, Cox proportional hazard, test public pH assumption. So this is when it gives me that chi-square. This is based on something called Schoenfeld residual. This is the pH test, but we have as well graph which is log minus log. Let's see where we can find it. I think let me check again. Regression. Okay, I think it's okay. So independent variable, let's say we put No, it's not here again. The minus log. Let me check if I have it on my slide. I don't have it on my slide, but there is an option. You can look it up and ask ChatGPT. So usually when we test the assumption of proportional hazard, you can check it either by statistics, like here, a global test, which is a chi-square test. It's called Schoenfeld test. Or you can test it by graph. As I said, the log minus log graph gives you, they should be parallel, the survival curve for the different groups of the main variable that you are testing for. Most important is that when the proportional hazard, what you are testing is that, or the assumption is that the effect of the covariate on the hazard is constant over time. And it means that they don't change over time. And if there is a violation, then the risk will not be, it will be biased. So what you should do then is to account for the time when you do the when you look at your covariate. يعني الcovariate ما بيكون independent of time, بيكون dependent on time. So therefore you are looking at the treatment effect based on the time when it happens, because you think that when it happens it makes a difference. So then the effect of the covariate would be different. So the effect of the covariate after 4 months would be different than the effect of the covariate at the end. And this is what the proportional hazard assumption does. All right. So any question? I think you'll be good with this data. I'm going to give you a small data set that you will work on. It will be worth just 5%. But and to make sure that you have really you have done it, please download the data that I will put. And it won't take you much. I want you to analyze the data and report the result. I'll have a forum or a forum where you would individually upload your result and interpret them. And you can work either with SPSS or Stata. I don't care, as long as you are able to generate survival data and do the survival analysis and able to interpret this very basic survival analysis data for cohort analysis. Any questions? Let me.
دكتور هلا الشيت
Yeah.
اللي you uploaded for Stata هي it's
Yeah.
not Excel فنحن لأنه عم نفتحها على
ما أنا
VLabs
لا بدك
ما كيف بدي افتحها to upload it on VLabs because I can't copy paste مثل ما كنا نعمل بإكسل.
So what do you usually do with Dr.
On
Dr.
VLabs you
Jafar?
have
تعطينا
to
إياها Excel and we copy paste it على
Okay, I can
Yeah.
convert it to Excel and I can send it to you. Okay.
Okay, great.
Okay. I've never worked on VLab, by the way. Never. لأنه حتى all the work that is done was postponed. So when there was an issue of closure or online, I would wait until we do everything in the lab. So this time we're doing it together, and sorry, I don't have this. I've never had this experience, so I will convert it when we finish and send you this one and the one that you need to work on as an Excel sheet, as an Excel file. All right. Okay. Any further question? So we're good. Razan, I didn't hear you. So are you with us?
Yes, Professor, sorry, my Wi-Fi isn't the best today.
It's okay. It's okay. But we lost people. I don't know who we lost. So I don't know. Rahman, Mary, Palestine did not join today, right? And I'm not surprised anyway. Bussola is here. Sadil was on her phone. And it's not easy to be on the phone, but we lost Sadil. And otherwise, everyone is here. All right. Let me stop sharing. Okay. Share. No more sharing now. Okay. So you have everything on Moodle, all right, except the Excel. And I hope you did have a chance. it's a lot. I just want to tell you that at this time of crisis management, actually we have more things to do. And we had a meeting, the faculty yesterday, and the online, and it's not evident for you maybe, but the online and the preparation and what's going on around us is taking really a toll on us. So it's much more work. I'm not trying to justify or say anything. But again, like yesterday was full of meeting. And for me, I thought that already I sent you instruction about today's session because it's already on Moodle. So on Moodle, you have everything with the article on mortality. I don't know if you read it. Did you read the article on mortality? Have you had a chance? Did you check Moodle? And
Yes,
can you
yes,
please,
Doc.
and
Yes, and I
yes,
read
Yes,
it.
yes.
okay.
You sent that.
So
You sent us on WhatsApp that you
ما
uploaded
شفت
it.
ما
Don't
عن
worry.
جد عن جد Maggie. Honestly, I don't recall what I'm because it's so much. So I'm always on WhatsApp group. I'm talking about professional group. I'm not. I only have WhatsApp group for my family made of 4 people. That's the only WhatsApp group I interact with. I mean, an informal WhatsApp group. Otherwise, all are professional group. So even sometimes the meeting, the discussion, they happen there. So I was not sure whether I did send you something. So great. Let's go over and you have the application, right?
Yes,
Great.
Yes,
Thank
yes.
you.
yes, you
Okay.
uploaded it as well.
Okay, great. So let's open the application. The article. Oops. Yeah. The article is okay. Again, ladies and gentlemen, I'm not trying to justify that I forgot. I'm not trying to justify sometimes the confusion, but just saying that this is what's happening. This is the status quo of what's going on in this abnormal situation. I mean, so we do try our best actually to be, and has been discussed yesterday. We try to be flexible. You are our first line of service, so we should care for you, for your well-being, for making sure that you that you do the learning, that you get the learning that you need. So we don't want to compromise any learning, and we'd like to. The university is trying to salvage as much as possible the semester. You know that nothing has been postponed except the date of withdrawal. We might little bit extend the semester, but still no official communique. But this is under discussion. Again, without delaying the graduation. So graduation is still at the same time. I know you're not graduating and you don't care maybe for the commencement. Some they do, and they want to have a commencement irrespective of whatever is happening. They want, and people have plans after the graduation. So if you say, let's postpone 2-3 weeks, and they would say, no, I want to travel, I want to finish, I have my plans, I have a job offer. So all this is discussed. So irrespective, no matter what decision we make as a university, you cannot please everyone, right? So you have to think about those graduating and those who are traveling and those who are displaced, and you are all a priority. But I mean, no one decision can be fair enough to everyone, right? And I mean, people would argue, but we are the majority, but we are in the dorm, but we are so no matter what you do, that's why we always keep in mind actually everyone. So now this article. So anyone would like to start? Let me get the questions. So the question are, I don't know if I can do splitting and putting the question. What do you think? We can do that? Have you had like a session where people split
I think
Yes,
the
we
we
did
can.
that on
screen?
Team.
Share.
Doctor,
What's
but I think we don't have enough time. So if we discuss the question all together,
Tab yellow. Okay. Okay, that would be good. Thank you. I think that would be a good header. Let's do quickly and then, but I would expect you to be okay. Okay, خلينا بعدنا. We're still sharing I'm still sharing the article. Yes. Okay.
Yes, it is.
Okay, so so the questions are not many. So the question are to state clearly two main hypotheses of the study. I'd like first to talk about quickly the method. Anyone would like to a little bit summarize the method? So what kind of cohort is that? Waves, cohort, so anything about the cohort?
Yes, I can do that.
Yes, please.
So they use the enhanced data, um, which they had, يعني, the people that were included in the enhanced data, and here we see the follow-up through several years in the 1982 to 1984, where they did the first follow-up of the people that were included in the first study, and then they did another follow-up. They did three follow-ups. And they wanted to see the association between depressive symptoms in those that are diabetic and their association with mortality risk. Also, they used a non-diabetic group to assess also the depressive symptoms on mortality risk.
Okay, great. So the people, it's good always to know who are the people that are HIDA. So this started in 1971, as you see. So who will enhance is those national studies that are done in all the U.S. In all the states of the U.S. And this is so this one, and second is this one. There is a follow-up. So actually, all these national studies are done routinely, like every 5 years or every 3 years, but they are done on a different sample, right? So that there is the National Mental Health Survey, the National Household Survey, so on and so forth. So every few years it is done on a different subsample using the same sampling methodology. And the actual aim is more to see trends over time related to NCDs, related to cardiovascular risk factors, smoking, other prevent public health measure like seat belt use, obesity, so on and so forth. But this one, so we have the enhance, and then we have the follow-up of the enhance, and the study population are drawn as a probability sample. So it's important to note that the baseline is a probability sample. So the study is first on a probability sample of non-institutionalized US citizen, and the age group is 25 to 74, and this is 14,000. And the vital status of 93% of the sample was traced through 1992. So it's good to know just the result. And then they talk about how many had baseline diabetes, because it's all about looking at looking at the depression and mortality, and looking at how diabetes is affecting this relationship. So what's happening among diabetic in terms of depression and mortality and non-diabetic. And they particularly highlighted that there's a subgroup of adults who had baseline diabetes, and these were 9,990. So again, when we have this kind of information, it's always good to have some kind of a flow chart. So let's say what was the total, and then how many have diabetes, how many don't have diabetes, how many have information on depression, because also if you look at the right left, these are very important to highlight and to read and to keep in mind when you read an article. So put notes on it. So if you look here, So first, the vital statistics, how many they had information on their vital statistics. So they identified 229 diseased cases in the diabetic and so many in the non-diabetic. And the vital status was based on death certificate, 98%. So what do you think the outcome? It's good, right? When you have 90% from death certificate, right, ladies?
Yes.
And Jan. So this is one. So important to see how did they collected the data on mortality. It's very important, death certificate, because we consider that this is really the best source of mortality. And only 1.3%. You can talk about it, but I don't think it will really make a big difference. The other thing is that we had missing, incomplete, on date of follow-up, to loss to follow-up, and SSD scores. So we have 156 with diabetes, 233 without diabetes who were excluded also from the analysis. So this is another issue. So is there potential for selection bias excluding these people who we don't have information on? What other information can we collect them? And then the one that were analyzed, then they tell us how many are dead. So among the diabetic, which we left with 558, and the non-diabetic, which are the 7,000. So these are very important. And when we talk about analysis, what type of analysis they use in this article?
They use the survival analysis.
Survival analysis, because they have the data, the time that elapsed from the time of the interviews and when they, the interview meaning when they assess their depression and diabetes to the date of death or censoring. Okay, so and then the date of death is the event, right? So the failure is dying. The survival time in weeks, so they specify that survival times in weeks. This is very important, again, to note. The method is very important to understand, and very important for you when you write your method is to be very clear. And when you write it for your proposal or your final paper, it needs to be reproducible with very much detail so people can actually evaluate how well you've done, whatever conclusion are based on the way you have conducted your study. So date of the interview, date of the later follow-up, so date of the last known to be alive as reported by proxy. Okay, so because sometimes you call back, you don't find the person, you have to call a proxy to see when that person last time was known to be alive. And then we have the variable, which are depressive symptom, demographic, lifestyle, etc. A lot of detail on how they assess depression based on the Center for Epidemiological Study. This is depression scale, SMOSSD. It's a valid one. I think it's validated as well in Arabic. And they control the covariate for age, gender, marital status, so on and so forth. Okay, so what are the hypotheses? Clearly, the two main hypotheses. Can you state? Anyone can state. Tasneem, can you state the main hypothesis of the study? What they are looking for?
Yes. One of the hypotheses is the depressive symptoms are associated with increased mortality among patients who have diabetes. And the other hypothesis is the association between depression and mortality modified by diabetes status.
Okay. So this could be, I would accept the second one. The first one is not well stated because it's not among diabetes that there is an association. Can anyone just have a more general hypothesis about the study? What they're trying to look at? Yes, Rula.
Yes, maybe depressive symptoms are associated with increased mortality in both diabetes and non-diabetes. And then the second one would be to look at the differential association between those with diabetes and those without.
You can say that and among diabetic, depression is more associated. So this is what you expect. But in general, first is that depression is related to mortality among diabetic and non-diabetic, but the association is different among the two groups. Thank you so much. So what do you learn from table 1? So that's the question. We'll go over. So what do we learn from table 1? Why table 1? What do we learn actually? It's a lot in table 1. So what do you learn?
It adjusted. The estimates are adjusted for the
Table 1, no
varies.
adjustment at table 1. Table 1. It's based
showing
on
the
characteristics.
Descriptive statistics showing the baseline characteristics of the patient.
What mainly they present? You know,
The
when you read
mortality.
it at the beginning, what do you see at first?
The mean survival time, which we can relate to mortality.
Of course. So the first thing is survival, right? So they're
Yes.
providing information on the main outcome at the beginning. Main outcome and what? And main exposure. So when we say descriptive, it doesn't, it comes to our mind انه age, gender, ما بعرف شو. لا, descriptive is two. Descriptive is profile of your population, because we'd like to know who we are talking about. Who are these people we are included in our baseline and follow-up, or actually here on the follow-up. And so this one is اسمه profile, which are also baseline characteristic. But the most important is actually the distribution of your sample according to your outcome and according to your main exposure, right? And then what they show as well. Do they have a total? Do they have a total? What else? شوفوا التable is very rich. So the table gives you, look at the beginning.
They also showed for the depression score the cumulative and they as well as the cutoffs.
Excellent. So very detailed on the cumulative. But one important, one important way. So we have an original sample of 9,000, but they show it according to diabetes. So whether there are differences by the two groups that we are interested in. So we're looking at diabetic and non-diabetic. So they're looking at, is the profile of the diabetic different than the profile of the non-diabetic? Who are these people?
Yes,
So
and they found statistically significant differences between the diabetic and the non-diabetic.
And non-diabetic, exactly.
Yes.
So so more importantly, this is what they look for. So they look at the main variables and the potential confounder according to diabetes. Right? Because they are considering diabetes as like stratification variable, because they, from the beginning, do you remember when we talk about effect modification? This is an a priori effect modification, right? Because it's built, the study is built on looking at diabetes as stratum specific, in everything as related to diabetes or modified by diabetes. That's why the first table not only shows baseline, but as well look at the differences between diabetic and non-diabetic. But it also shows you how many are diabetic, non-diabetic. It shows you the event among diabetic and non-diabetic, right? شوفوا قد ايه في. Look at the data. Are you seeing those data? Are you seeing my cursor?
Yes. Yes, doctor.
So it's Anna, if I don't give you the table, so if I don't give you the text, you have so much information, by the way, from the table. There is so much detail in the table that you can yourself narrate you can do the narration. Okay, you don't have to go back. I can have so much information, and of course, it does indicate the which is significant, which is not. What are the different categories? And I think the significant, right? Yes, significant difference between diabetic and non-diabetic. This is by this sign. So also we would know which are different, statistically different. Okay, so other than using the mean survival time, how can you compare the survival experience between diabetic and non-diabetic based on the table provided in table 1? So what we can do here, if you want to compare diabetic, non-diabetic, we can see that the diabetic, the survival time is shorter, right?
Yes.
مظبوط. And it is
Yes.
statistically significant because this sign tells me whether there's significance between diabetes. What's another a way of comparing survival experience between diabetic and non-diabetic, just from that table that I just talked about? Busola. So we use the mean survival from that table.
The mortality.
Yep. The death. So 276 out of 2558. This is probability of dying among diabetic and probability of dying in non-diabetic, which is 1499 over 5564. Right? Sorry, 1499 over 7063. So from the table, if I tell you that, can you calculate an incidence rate for a diabetic and non-diabetic and get a relative rate, a relative risk for death by diabetes, I think you have it as well. So you have the survival and then you have the event. Everything is here. I think it's really very nice. It's a very nice article that's very well written. What about this one? So we have figure 1. So now
We can look at these curves also to
yes. So
you
how
know, to indicate
what you can get? What can you have? What is it that you can get? Yani comment on this survival.
probability of surviving over time. لأنه
Yes.
it's one for the diabetic population and the other one for the non-diabetic population.
Yes. No. This is one is a yes, in a diabetic population stratified by S, and this is. So what you find?
And those with diabetes will live less than non-diabetic over time.
Okay. So with diabetic, so لا, it is depression and death among diabetic, depression and death among non-diabetic, right? So in this one, if you are not depressed, I mean low depression, mild depression, this is your survival curve. If you have severe depression, you have a poorer survival, right? Is the difference by, look at in this one, it looks like depression is much more difference and survival by depression score for diabetic. Let's see the non-diabetic. So what do you think? Using the same scale, same scale, right? Same grouping for SSD. Is the difference large and similar to this one? So the difference when you have depression and mortality is still mortality. When we have high depression score, mortality is higher, less survival, worse experience. However, is the difference large?
No, not really.
Not really,
As
right?
compared to the diabetic
As
population, no.
compared to among the non-diabetic, among the diabetics. So again, this is another way of portraying, of looking at the graph visually. Actually, a graph is worth 1,000 words. This is what they say, right? And this tells you a lot. And of course, we don't have the magnitude. We don't know if this is statistically significant, but we can do that. Can we
say?
Can we put the two graphs together, do you think, and then come up with
If
I
they
mean,
have the
like
same scale, I
diabetes,
think
depressed,
yes,
diabetes, non-depressed?
because they have the same scale, I think.
فينا نحطهم يعني we could have
Yes.
put actually, right?
Yes, we can put them.
Yeah,
وبصير عنا 4 curves.
If you recall,
diabetic
yes,
is more
Abdulrahman.
steep. The diabetic is like steeper with a greater slope, negative
مظبوط, the
slope.
diabetic and deeper slope, excellent. So the diabetic have deeper slope, so they die quickly. The rate of dying is quicker. 2 is the depressed is the lowest, depressed and diabetic. So if you recall the one on cardiovascular diseases and cabbage and looking at the renal failure, diabetes, and renal failure and cardio and peripheral diseases. So the people who had 4, so diabetes, so it's here diabetes and the depression, they have the lowest, the worst experience. And I think they could have done it. They could have put it together. I would put it together. I think it would be, and then compare the 4 groups using the log rank test. Here they don't report a log rank test, but they could have done that. So Okay, so we can combine the two groups, right? So this is what I said. So what do we still need here to make some kind of a conclusion that's not here, at least on the graph? What do we still need? But just to make a little bit of a conclusion about the graph, what is still needed to test whether the
Unless you to
differences
indicate
is...
significance,
Yes, exactly.
something.
We need a logrange. Okay, we need a
Yeah.
test. We still need a statistical test to tell us whether the two. Usually we put it and people put here the p-value. Maybe it's in the text. I'm not 100% sure. Okay, so we go to 6. What's the main purpose of table 2? So this is table 2. So table 2 is comparative model of depression mortality association between diabetic and non-diabetic. So what are these hazard rate ratio? So first they're saying that this is analyzed with dichotomizing the SSD score. So that's how the SSD score are analyzed 1 to 15 and 15 plus. And then what are they doing here? They're reporting the association of depression. So let's look at the title, a comparative model of the depression mortality association between diabetic and non-diabetic.
Mortality risk.
Here they adjusted, doctor, for the other covariates.
Okay, but when looking at the demographic, the white and race, so on and so forth, so this is what? So is this hazard ratio of depression with mortality, or it's age and mortality?
Depression with mortality adjusting for age.
Yeah, they have the.
No.
You
So
can see.
okay. So
It's,
first
they have the
look
depression
at,
score
yeah.
with.
So they
yes.
combined. Actually, they combined in one table the association of the covariate with mortality among diabetic and non-diabetic. So these hazard rate ratio are for the covariate. So this is demographic and socioeconomic. These are all the covariate that includes very well ordered the demographic first, the lifestyle, the health status, diseases, and then they put the SSD overall, and then the other one, the analysis with the categorize, and then they say here is where they say they put the test, and then they include the covariate. Okay. So first, these are unadjusted association of those covariate with mortality for diabetic and non-diabetic. Okay. Okay.
Yes, doctor. And below they adjusted for them.
If you look at this, so let's look at, this is the stratified data, right? Check. What kind of strategy we're using here? We're just looking at the data stratified by diabetes and then looking at the hazard rate ratio of mortality for diabetic and for non-diabetic. What do you conclude? Okay, at least what we see here, first, if we look at the moderate depressive symptom, you have an increased risk of dying for those people who have 16 to 21 compared to less than 15 and less, right? So the reference is low or no or low depression, right? Are you with me?
Yes.
Okay.
Yes.
Yes, doctor.
It is statistically significant, right? This is for diabetic. For non-diabetic, the association, the hazard rate is 0.93. It's not protective, and it's very close to 1. And if we look at the confidence interval, it includes 1. So based on stratified data, do we have heterogeneity or homogeneity? So if we look at homogeneity tests, so they are heterogeneous, right?
Yes.
At least we're talking, I'm not saying go and test it. I'm just saying that if you examine the data suggests a significant association of depression with mortality for diabetic and no association for non-diabetic. This is for the moderate. If we look at the severe, again, it's 1.49. Still, the association is significant, and it remained non-significant for non-diabetic. They again changed the SSD, and with a 1 year lag, so they little bit pushed with a 1 year lag. Again, the moderate lost its significance. However, the severe remained significant, and again, the association of depression with mortality was only statistically significant with diabetes. So does this at least indicate that diabetes is an effect modifier? Or at least it does the depression, the effect of depression on mortality is modified by people's
Yes.
Diabetes. And of course, one can think, and they have very well explained how this would happen. I think these are actually adjusted, if I'm not mistaken, the final one. So can we, at the end, okay, so the author used survival analysis to study the association of depression with mortality. How can you analyze the data differently, taking into consideration the nature of the study and the population being studied? What can you do differently? On survival, how else can we present the analysis of the data?
We can put it as a binary result, not necessarily as a hazard ratio.
Okay,
So
but
yes,
if
no
you want to
mortality,
take
no
into
mortality.
consideration, yes, that's excellent. So this is always the binary actually is always an option, Rula. But if you want to take advantage of the time, and then if you know that people are you have lost to follow up, you have people who we lost them, we might not have maybe equal follow up period. What would be your second option?
Maybe per incident rate ratios, maybe per
Yes,
person
yes,
year.
person years. Yes, person years. Person years actually does account for. So if you're not a lot interested in the time to event, but you want to take into consideration the amount of time at risk rather than population at risk, I think for each one of them, since you have when they died or when they were censored, you can have person years. And in some many paper on follow-up, they do provide you with all of this. And if we put this data on survival, and as you've seen, it can generate person year data. So once you generate person year for every person, and then for the groups, you can calculate incidence density rate rather than Cox regression or survival data, and then calculate incidence density rate ratio, and which is really very possible. And of course, for every type of study, we can do an odds ratio. But I would do a person incidence density rate to make. Oops, sorry, 1114. I apologize. Let me just quickly say, is this a cohort? Oshie, can you conclude that there is a causal association between depression and mortality? Give me two reasons why would you say that there might be a causal association quickly.
First of all, it's a cohort study,
Temporality.
so the
Cohort.
temporality
Yes,
confirms
excellent.
the
Perspective.
What would be a
and the
second
strength
one?
of association. The
And
strength of
The strength is
association.
not much. The strength is not much.
Confounding. We looked at the
Yes,
confounding.
excellent. So confounding, it is controlled, and I would say the dose response. How is it? I know that there's no dose response, but if you look at the not much about the depressive symptom, but yes, you're right. I think the most important is the element of the cohort. But I think when they consider the different categories of depression, I think they wanted to look at some kind of a dose response, but maybe it was not very clear. I think there's yes, بس خلينا بس please بس to address the pan, and if you have question you can ask. I think the last question is very important because we don't get much to discuss biases, and it's important to understand what are the consequences of losing people and excluding people. And that's why I told you, and the part of the method, they talk about excluding those who don't have diabetes at baseline, or those who they don't have information on. And this could create selection bias, because if those people have different depression symptom, right? We lost them because they are more likely to be depressed. Okay, so this it means that we are actually have a selection bias that could underestimate the association. So we don't have enough people who have depressed and yet they are dying. So we might have a selection bias just by looking at those people who died, and we should of course collect much more information on them. But I want you to think more about the selection bias and maybe any other information bias that could occur from this text, and maybe read well the discussion to see what are the author's reflection on some of the shortcoming of the study, some of the potential biases, and how these could have affected my study result. Okay, and if people want to ask question, I'm fine. But for people who want to leave and have other commitment, I understand you can leave. Okay. I hope this was useful. I'll put the key. I'll put so you need from me the Excel file and the key to that discussion, right?
Yes. Thank you,
Okay.
doctor.
Okay.
Thank you so much.
Doctor,
Okay.
I have a question.
Yes.
Doctor, when we were discussing the causal association, إنه نحن we said إنه there is temporality and its cohort, and we accounted for several confounders. بس could it be مثلا إنه reverse causation؟
It could
مثلا
be.
إنه
They talked a lot about reverse causation
yeah.
actually. But again, you have to see how they started. But because it is mostly related to reverse causation with what? ما نحن we're talking
Yeah.
about death, Janine. Janine, was it Janine?
Yes.
So
Doctor,
we're
أنا
talking about,
قصدي
and I'm talking about depression and death.
mortality.
Cannot
Yeah.
be. It cannot be.
Yeah,
عم
yeah.
نحكي, is it a causal association? Or it is maybe through, I don't know what. So I think it's
أنا
the,
I meant إنه depression, sorry, diabetes, إنه diabetic person will have إنه more prone to get depression.
it could be,
And
it
this
could
is
be
what I
either
meant
way,
for
by
the
the way.
causal
It could be,
association.
it could be, it could be. And there's a good, actually, a good discussion at the beginning. And the background is very rich and they they explain about I mean, the diabetes, leading to depression, for instance, because of all the hassle of dealing with diabetes, and depression also leading to diabetes, because when you are depressed, you don't take your medication, and it can relate to, they explain actually even some biological pathways. So it can actually, it can go either way. But we're talking about more as a causal association between depression and I think so. Wasn't this a question, or was it about diabetes and I think between depression and mortality. We're talking about
Mortality,
depression and
yes.
mortality. It could be mediated by diabetes. It could be direct, but it could be as well because you have taken diabetes alone, and still there is an association also between diabetes and between depression and diabetes. Some dose response, maybe, I'm not sure, but cohort, yes, accounting for confounding. Strength is okay. We have to look at consistency of studies over time. And all these are, again, guidelines that more or less, and then you have to think about what would be a causal pathway, right? And what's the causal pathway that leads somebody from depression to death? Again, I'm not sure if they have talked about depression as increasing maybe suicide or something, but overall mortality is increased with depression. Okay, I'll hopefully, okay, I will stop recording. Okay, so it recorded all the session. I will try to edit, but I don't promise you that I will I will give you a clean copy of this presentation. But given that you have now the presentation on the SPSS, you have a PowerPoint, you have the SPSS, and you have your a chance to practice. So I hope that it will be good, and I will be asking you to submit, not now, but soon, a very small exercise on survival. And I hope you do it soon, so you won't, so just
Yes,
put
doctor.
it
Today's session was
off your way.
planned.
I will put it on the
So